Hi, I'm Desmond Edagese, and I welcome you to Maths class today. Today, we'll be looking at the theme, Everyday Statistics, and our topic for today will be on data presentation. It promises to be a very interesting class. Let's go on. In the course of our class today, I expect that you and I will learn what data is. Next, we'll also learn how to collect data. And we'll also learn the different ways of presenting data. And one of the first ways of presenting data is using pictograms or pictographs. We'll also learn that the bar chart is another way in which we can present data. And finally, we'll learn about the pie chart, which is also a way to present data. Let's go on. Now, the word data. What exactly is data? All right? Data is a collection of facts, such as numbers, words, measurements, observations, or even just description of things. But note that data is basically collected in number form. So either of the information gotten here are always converted into a number form so that we can make better interpretation of our data. When information from data is arranged in order from the highest to the lowest number, we call it the rank order. Now, in the course of our class, we'll find out that sometimes we arrange this data, this numerical data, from the smallest to the highest. But when we arrange them from the highest to the lowest, we refer to that as a rank order. The number of times something happens in our data is called frequency. Now, these are words that will come across a lot in the course of our study today. Remember again, frequency is the number of times something happens in our data. Now, these are examples of data that we could collect. Just some quick examples. For example, if you have a garden in your school and you counted the number of living things in your school garden, that would be a data. So you could have worms, insects of different types. Now, if you kept a number, say you have grasshopper, you have like 15 grasshoppers, you counted the worms there, you have like 20, you counted beetles and all of that. All of that information that you gather is what we refer to as a data. All right? You could also have some of the richest nations. So you could mention the United States of America, Great Britain, and so on. Also, your class score in maths. Maybe throughout the year, you had different tests in maths. If you kept the record, that would also be a data. So those are different samples of data. So now you know what data is. Let's go on to learn some more. Now, data can be collected in many ways. But the simplest way to collect data is by direct observation. So it simply means that you do not collect data by hearsay. For example, you ask your friends, do you know how many organisms we have in our school garden? And he gave you a number. It could be wrong. But if you did a direct observation by yourself, then you could easily get the correct data. So to be able to collect data, you need to be able to count. Remember the example of the garden that we gave. Now you would have to go to the garden and look through every square inch of that garden and count the number of grasshoppers you saw, count the number of beetles you saw, the number of worms, and so on. So you need to know how to count when you are gathering data. Next, you need to also know how to record data, that is to write them down. We're going to see a quick example of someone that tried to gather data. One person did it the right way, and the other person did not do it in the right way. Let's take that example. The total number of vehicles that crossed a street between 10 a.m. and 6 p.m., okay? 2 persons were asked to count the total number of vehicles that crossed their street. Know that they both live on the same street between 10 a.m. and 6 p.m. And this is what the first person did, okay? So he took a paper and wrote down taxi. That was the very first vehicle he saw. Next he wrote down car. Next he wrote down bus. He wrote down car again. And so on. At the end of the day, he had 22 vehicles. All right? At the very same time, someone else was also collecting data. But let's see how this person organized the data in a very good way. The person got a paper also, like our first guy, and he wrote vehicles, okay, at the top of the paper. Next, he wrote tally, and he wrote the total. And this is what he did. So he wrote below the vehicles the description of the vehicles. We have cars that cross the street, buses, taxis, lorries, bicycles, and motorcycles. Next, he tried to make a tally every time a vehicle crossed, okay? So instead of writing the number, this he did at a later time. He first wrote a tally. When a car crossed, he wrote 1 car. Another one crossed, he wrote 2, and so on. When he got to 5, he would cross it out. And this, of course, at a glance would tell him he has 5 vehicles. Of course, he had 3 extra. And when he did a count at the end of the day, he had 8. He did the same for every vehicle, and at the end of the day, summed up the number of vehicles he had to be 22. So this is a much better way of collecting data. Of course, if we took this example here, we notice that this person here could easily have made a miscount in the course of his putting down taxis, car, buses, and all of that. And at a glance, it doesn't tell us what we need to know. We have to do a count, taxi 1, taxi 2, taxi, like that. Okay? But this other record here, at a glance, we know that we have 8 cars, 1 bus, 4 taxis, and a summation of everything to give us 22. So this is a much better way of collecting data. Let's go on. Now, we collect data by doing what we call a survey. Okay? A survey is simply a critical analysis, or, in simpler language, studying a particular situation intently in order to get information from that situation. Now, we just gave an example of somebody standing on a street to count the number of vehicles that crossed the street between 10 a.m. and 6 p.m. What he did was a survey. All right? Now, there are 2 kinds of survey. We have what we call census, and we also have what we call a sample. When you take a census, it means that you have collected data for every member of the group. Let's take a typical example. If I want to take information for, let's say, your class, all right, GSS 3. Now, your class, maybe you have GSS 3A, 3B, 3C. And I want information on the favorite kind of sports that every student has within GSS 3. Okay, I would need to go through GSS 3A, 3B, 3C, and ask everybody and get their information and put it down on paper. All right? When I do that, what I've taken is what? A census. I took information from everybody in the group, every JSS 3 student within the school. But when I take a sample is simply collecting data for just some selected members. So instead of going through GSS 3A, 3B, and 3C, I simply select GSS 3B, for instance, and I ask them my question, what is your favorite sport? I get all the information, and I use that information as a general statement for all GSS 3 students. When I do that, that is called a sample. So again, there are 2 ways of collecting data. And each of this way, one is the census, while one is the sample method. All right, let's go on. Now, for any data to be easily read, just like the data we got earlier about the number of vehicles on that street, it must be presented clearly. All right? So I have my data in a table form, just like we saw earlier, but I want to present it maybe to someone or a group of people. I can make it colorful, I can make it very easily read and understood by making use of 3 different ways. All right? So I could use the pictograph method to present my data, or the bar chart method to present my data, or even the pie chart method. Now, these are 3 very interesting methods, and shortly we're going to look at each and every one of them and learn exactly how to make use of them. Let's look at the first one, the pictograph method. Now, what exactly is a pictograph? If you look at the word pictograph, okay, it's a joining of 2 words. So we have picto, which of course gives you an idea there are pictures involved, and of course a graph. A graph, of course, is a visual representation of data, all right, where we have axes on the left and on the right. All right, so when we join the 2, we call it pictograph. A pictograph is a way of showing data using pictures or drawings. So we use pictures or drawings. Each image in a pictograph stands for a certain number of things. Okay? Now let's take a typical look at a pictograph here. This is a pictograph of a fruit shop. Okay, the man sells apples. And we want to find out how many apples he was able to sell between January and April. Now, instead of using numbers, I can make use of a pictograph to simply explain that. This pictograph, for instance, tells us that each apple within our pictograph here represents 10 apples. If we have a half apple, of course, that tells us that we would have half of 10, which would give us 5 apples. All right? Now that we understand what each image within our pictograph means, if we took a glance at our pictograph here, we would easily understand exactly what this person is trying to present to us. All right? It means that in the month of January, he sold what? 10 apples. This one apple, remember, we said is representative of 10 apples. So he sold 10 apples in January. Next, in the month of February, he sold 10 plus 10 plus 10 plus 10. Each apple, again, remember, represents 10 apples. So it means that 10 plus 10 plus 10 plus 10 would give us 40 apples. So in the month of February, he sold 40 apples. In the month of March, he sold 1 apple, that's 10 apples represented, plus another apple, another 10 apples, that's 20 apples, 10 plus 10, and a half apple, which we said represents 5 apples. So he sold 10 plus 10 plus 5, and that would give us 25 apples. And of course, in April, he sold 1 apple representing 10 plus another 10 apples would give us 20 apples. So we see that in January, 10 apples were sold. In February, 40 apples were sold. In March, 25 apples were sold. In April, 20 apples were sold. All of this information can be easily presented to us using this pictogram here. Now let's take a look at another example of a pictograph. All right? The pictograph below tells us the number of students that got certain grades. So we have grade A, grade B, grade C, grade D, grade E, and grade F. Now, each image here represents 2 students. If we took a look at our pictograph here, it means that there are 2 plus 2 plus 2 6 students that got grade A. Also, 2 plus 2 plus 2 plus 2 plus 2. 10 students got grade B. For grade C, we had 2 and 2 students to give us 4 students for grade C. Grade D had just 2 students that got grade D. Now, 2 plus 2 plus 2 plus 2, 8 students got grade E. And finally, just 2 students got grade F. So we see that our pictograph here has been able to pass across to us the information that 6 students got grade A, 10 students got grade B, 4 students got grade C, 2 students got grade D, 8 students got grade E, and 2 students got grade F. Let's take a quick look at a last example. The pictograph shows the number of people in the Army, Navy, and Air Force of a country. Each tank, ship, and aircraft represents 10,000 people. All right? So, our airplane here represents 10,000 people. Our warship represents 10,000 people. And the tank also represents 10,000 people. Now, the question is, how many people are in the Air Force? Take a look at our pictograph here. The question is, how many people are in the Air Force? Remember, we said the plane represents the Air Force, and there are 10,000 persons per plane. So what we need to do is do a count of the number of planes. We have 1, 2, 3, 4. We have 4 planes, and each plane represents 10,000 people in the Air Force. It means that we would multiply 4 aircrafts or planes times 10,000 people, and that would be 40,000 people. So there are 40,000 people in the Air Force. The next question says, how many people are in the Navy? Remember, we said that the warship represents the Navy, and of course, each warship represents 10,000 people. So from our pictograph, we'll quickly do a count of the number of warships. We have 1 warship, 2 warships, and half a warship. Together we have 2.5 warships. All right? Remember, each warship is worth 10,000 people. So we simply say 2.5 warships times 10,000. And of course, if we multiply that, we'd have 25,000 persons. So we have 25,000 persons in the Navy. The last question says, how many people are in the Army? All right? The tank is the image that represents the Army. And of course, each image represents 10,000 people. If we did a count in our pictograph here, we have 1 tank, 2 tanks, 3 tanks, 4 tanks, 5 tanks, and 6 tanks. So we simply multiply 6 tanks times 10,000 people. And of course, that would give us 60,000 people. So there are 60,000 people in the Army. So we see that the pictograph is very useful when it comes to presenting information or data. Now, another means by which we can represent data clearly is the bar chart. So what exactly is a bar chart? The bar chart is a way to display data using graphics, which is basically the bars of different heights. All right? Now, bars that we mean are simply vertical rectangular boxes that may or may not be colored or shaded in order to differentiate them. Now, just like we learned using the pictogram or pictographs, we also make use of these bars to represent our data. So instead of using pictures, we make use of bars. The bars all have the same width and usually have equal spaces between them. Now, the bars are very distinct because the height of each bar can be used to represent the frequency of our data. Remember, we said the frequency is the number of times something happens. So when we have data that occurs a number of times, we say the frequency of that data is so and so. The height of the bar represents this frequency. Let's take a typical example. In this bar chart here, we are representing grades A, grade B, grade C, grade D, grade E, and grade F. The vertical left part of our bar chart here contains the frequency of each grade. So at a glance, this picture tells us that our grade A occurred 6 times. Remember we said the height of our bar represents the frequency. It means that grade A occurred 6 times, or 6 students got grade A. So when we trace the top of our bar there to the y-axis, that is the left part of our chart, we get the frequency. Again, the grade B occurred, let's do a trace quickly, 10 times. Or we say 10 students got grade B. Also, our grade C occurred, if we do a trace, we have 4 times, or 4 students got grade C. Our grade D, let's do another trace, occurred twice, 2 times, or 2 students got grade D. And the grade E occurred, if we trace it down, 8 times, or 8 students got grade E. Finally, our grade F, which of course is a fail, occurred, if we did a trace, 2 times, meaning that 2 students failed their exams. So this is how the bar chart works. Let's take a closer look at another example for better understanding, okay? Now we can use bar charts to show the relative sizes of many things. For instance, a survey of 145 people who chose their favorite fruits was given in this bar chart, all right? So quickly, on the left part of our bar chart, we have the frequency, while the other part contains our bars with different heights pointing to the frequency. This bar here represents apple. This bar here represents guava. This bar here represents banana. This bar here represents mango. This bar represents orange. This bar here represents pineapple. This bar represents pawpaw. And this bar represents cashew. So, each of the 145 persons were asked which of these fruits were their favorite fruits. And let's do a trace to find out how each person, gave their answer. First, if we trace the bar representing apple to the left part, we'll see that the love of apple was recorded 15 times. Or, in other words, we say 15 persons out of the 145 persons loved or preferred the fruit known as apple. If we did a trace for guava also, this bar representing guava, if we trace the top down, it tells us that guava had a frequency of 30, or the love of guava was recorded 30 times, or 30 persons loved and preferred the fruit guava. So for banana, we have 40. For mango, we have 20. For orange, we have 35. For pineapple, we also have 20. For pawpaw, we have 25. For cashew, we have 10. 10 persons loved and preferred cashew. Now, another thing to take note of when using the bar chart, just like we have our headings here, that is the number of people or the frequency of the likes of those fruits by those people, stayed on the left while we had the fruits on the other end of our chart. These headings of fields can also be flipped over. So we could have a reverse of what we had in the other chart. The favorite fruit could also come to this left part of our chart, while the frequency or the number of people comes below. So we notice a reversal of our bars, which are now facing the right direction, and they are horizontal, no longer vertical like it was in the first instance. So you can have either way as a way to represent your bar chart. Either you put your frequency on the left part or you put it below. Either way is correct in the usage of bar charts. Now let's take a quick look at this example. The bar chart below shows the rainfall in centimeters in Kano for each month in a year. Let's say the past year. Which month had the most rainfall? To answer this question, let's take a quick look at our bar chart here. The month that has the most rainfall will simply be the month that has the longest or tallest bar in the bar chart. If we took a scan, we'll notice that the month of August is the month that has the longest bar in the chart. So August becomes our answer. August is the month that has the most rainfall. The next question says, how many centimeters of rain fell in the second wettest month? The first wettest month we've already found to be August. August has the tallest bar in the chart. The second tallest bar would be the second wettest month. And of course, that bar belongs to the month of July. So we've been asked to find the centimeters of rain that fell in the month of July. To do that, we'll do a trace to get the frequency, and that would be 25. So 25 centimeters of rain fell in the month of July, which is the second wettest month. The last question says, the dry season is when the rainfall is 5 centimeters per month or less. It means that every month that has 5 centimeters or less than 5 centimeters becomes the dry season. All right? We've been asked to name the months that fall into this category. That is the month that had dry season. Let's take a look again at our chart. We'll find that the month of January, if we go through each month, January has no bar, and therefore January can be categorized as a dry month or as a dry season. All right? February also, if we notice, has no bar. It also qualifies as a dry season. March has about 2.5 centimeters, which is less than 5, and therefore it also qualifies to be a dry season. The month of April has exactly 5 centimeters of rainfall. That means it also qualifies to be a dry season. May has 10, so it does not qualify. June has 20, does not qualify. July has 25, does not qualify. August, of course, has the most rainfall, doesn't qualify. September has 15, it doesn't also qualify. October has exactly 5 cm rainfall and therefore qualifies. November has no rainfall, qualifies, and December also has no rainfall. So this month, January, February, March, April, October, November, and December qualify to be called dry season. So we have January, February, March, April, October, November, and December as the months that had dry season. And of course, that is our answer. Now, another means by which data can be presented clearly is what is known as the pie chart. The pie chart. From the name, we get an idea. The chart that looks like a pie. And of course, we all know that a pie is round in shape or circular in shape. One popular pie that you and I know, called the pizza. We know that the pizza is round. And of course, when you bring the pizza home, what happens? We share it, right? So you have slices. The pie chart is simply a graph that has the shape of a circular pie. Now let's take a typical look at what a pie chart looks like. This pie chart here, at a glance, tells us the different kinds of movies 20 friends like best. 4 friends out of the 20 like comedy. This area here contains the friends that like comedy. 5 friends out of the 20 like action, and of course, it has a different color. 6 friends out of the 20 like romantic movies, and of course, they are colored red. Just 1 person out of the 20 like drama. Hence, we see the slice here, the slice of the pie is very small because it's just 1 person. And again, lastly, 4 persons also like science fiction movies. And hence, we have a different color. So for every category of movies, we have different colors representing the different segments or divisions of our pie. It's like a share of the pie. So we notice that the bigger the frequency, for instance, we have 6 persons liking romantic movies. 6, of course, is the highest in category to all the other movies. Hence, we notice that these 6 persons have a bigger percentage or a bigger slice of our pie. Let's go further and see how we can better understand it. Now, each slice of the pie, just like we saw just now, is mathematically known as the term sector. So each slice of the pie is a sector of the circle that represents the size of data in question. To figure out the size of each pie slice or sector, like we now know that the name is, we follow 3 simple steps, all right? We divide each value. That value is known as a frequency. Of course, by now we know that. By the total frequency of our data, and we multiply it by 360 degrees. We do that because the sum total of angle in a circle is 360 degrees. Okay? Next, we draw a circle. If you are using a paper, we're just showing steps. If you've been able to calculate each value to get the sector, all right, you draw a circle on your paper. You can make use of a protractor. And you can also use the same protractor to mark out your angles. So if you do that, you could have something like this. This could be 25 degrees, 40 degrees, 30 degrees, 120 degrees, and so on. But whichever way, the sum total of all angles here must be 360. And that's how you go about to draw your sector on a pie chart. Let's take a typical example. From the table given, the size of each sector represents the number of students with grades A to F. All right? So we have grade A, grade B, grade C, grade D, grade E, and grade F. 3 students got grade A, 5 students got grade B, 3 students got grade C, 1 student got grade D, 2 students got grade E, and 1 student got grade F. In total, we had 15 students. This 15 is gotten by the summation of 3 and 5 and 3 and 1 and 2 and 1. Okay? Now, to get the angle of each sector belonging to each grade for the number of students, what do? For grade A, we've seen the steps. You simply say 3 students that had grade A all over the total number of students, which is 15. So we have 3 over 15 multiplied by 360 degrees. If we did that, we'd have 72 degrees. All right? Hence, we have the angle of the sector for grade A to be 72. Same thing for grade B. You have 5 students that got grade B. 5 students all over the total number of students in that class, 15 students, 5 over 15, times 360. That would give us 120 degrees. And that's how we came about that. And so on. If we did the same for all our grades, we would have all these grades. If we summed up 72 and 120, and 72 and 24 and 48 and 24, would have a total of 360 degrees. So now that we know the sector, we can go straight to our third point there to use your protractor on a paper and mark out these degrees. So you can draw this on your paper. Of course, our grade A, 72 degrees, this would be 72 degrees. Our grade B had 120 degrees. Our grade C was 72 degrees also. Our grade D was 24 degrees. Our grade E was 48 degrees. And our grade F was just 24 degrees. All right. On paper, you can make use of your protractor. Your protractor is a mathematical instrument, of course, that you use in drawing and measuring angles to get an exact pie chart. Let's take a look at an example. The pie chart shows the division of money that a government spends on universities, teacher training colleges, secondary schools, and primary schools. Now, which of the four institutions get the least money? All right? We have a pie chart that is already drawn for us. And we've been asked to identify which institution gets the least money. Now, in pie charts, we said each sector is represented by different colors or shades in order to differentiate them. The color here represents universities. The color here represents teacher training colleges. The pink color here represents secondary schools, and the red color represents primary schools. All right? So at a glance, we can quickly identify which sector belongs to the categories of institutions. Let's visit our question again. Which of the four institutions gets the least money? At a glance here, of course, we'll notice that the universities here has the least slice. Or the sector here is the smallest sector amongst other sectors in our pie. And that simply answers our questions. Universities get the least money. All right? The second question says, what fraction of the money is spent on primary school? Now, the color that represents the primary school is the red color. If we took a look at our pie chart, we'll notice that the red color here, or our red sector here, represents exactly half of the pie. So we can simply say the fraction that we have been asked for is half, exactly half. We have a straight line that cuts across the center of our circle to have a diameter that cuts the circle in half, or cuts our pie in half. So we have half of the money to be our answer. The fraction of money spent on primary schools is exactly half of the total amount. The last question says, what fraction, again, of the money is spent on secondary schools? The pink colored part of our pie represents secondary schools. If we take a look at our pie chart, we'll notice that we'll have a quarter of the circle as the part belonging to the secondary school. Exactly a quarter. That is a half of a half. And there we have a quarter. So it means that a quarter of the money is spent on secondary schools. And that's how we make use of pie charts in presenting data. Now, in summary, let's do a recap to see all that we've learned today. We learned what data is. We said data is simply basic information, usually in form of numbers. We also learned that when we arrange numbers from the highest to the lowest, we call that the rank order. We learned that frequency is the number of times something happens. The number of times a particular record in our data, is recorded. Data, we said, can be collected by direct observation. Okay? And we also learned that we collect data by doing a survey And we said a survey is either a census or a sample. We learned that data, when collected, must be presented clearly, or else it will not be easily understood. And to present this data, we learned about 3 different ways in presenting data. We learned about the pictograms, which makes use of images that represent a number of records. We also learned about the bar chart that makes use of vertical columns that are rectangular in shape to represent our data. And lastly, we learned about the pie chart, which we said is shaped like a pie circularly and divided into slices or sectors to represent the different data. To test ourselves, let's take 1 or 2 questions quickly and see how far we've learned. The pie chart shows how the students of a government school in Abuja come to school daily. All right, this is our pie chart here. And it shows us the different means through which students come to school in a government school in Abuja. Which of the 4 means of transportation is most used by the students? Most used. From our question here, we'll simply know that the means of transportation that would be most used will be the slice or the sector of our pie that is the biggest. All right? So let's take a look at our pie here. At a glance, we notice that this sector here, which is the sector that has the means of transport known as walking, has the biggest slice or the biggest sector. So quickly, we simply know that walking is the means of transportation that is most used by the students. Let's also take a look at the next question. The bar chart below shows the grades recorded by students of a class in geography examination. The grades are A, B, C, D, and E. How many people got grade B? At a glance, we quickly go to our grade B and we identify the bar on our grade B to trace the top of our bar to the frequency side of the chart. And of course, it gives us 7 as an answer. So it means that the grade B was recorded 7 times, or 7 persons got grade B. Our options here has option C as our correct answer. 7 persons got grade B. And with that, we've come to the end of our class today. I'm sure you've learned so much. I look forward to seeing you in my next class. Bye for now.